linear law is basically all about finding relations that we can show as straight lines. Okay. And straight lines are basically useful because we can easily figure out how one thing changes with respect to the other. And we can also figure out distances, gradients, all the coordinate geometry stuff that we've talked about, that we've learned over the years. So this is quite useful for that. But obviously, the first thing is if we have a relation that isn't really a straight line graph, or a relation that isn't really a linear in the sense that it's not a straight line, then how do we fix those, and how do we actually use the linear law to show them as a straight line? Okay. Now, for that, what we need to understand is that mostly if you have a separable relation, a separable relation is basically in which you can have x on one side and y on the other side. Then it's very easily possible to show it as a straight line graph. So a simple example of that was the one that we were talking about last time. It was that we had y equals x squared. Sorry about that. So we have y equals to 2x squared plus 1. Now this is simple quadratic relation. I'll show the graph to you. So if you look at this graph, so if you look at this one, the relation is basically y equals to x squared plus 1. Okay, so that's a relation. We can see that y changes quadratically as x increases. So it's basically a curve. But if you want to show this as a straight line, what we need is a dummy variable. Okay, so dummy variables are basically variables that we assign a combination of x and y. Now remember, because it's a variable, it cannot have constants included in it. Okay, so constant cannot be there. What that means is that you can't have ax squared to show a dummy variable x. You can't, but you can make just the x squared as a dummy variable. Okay, does that make sense? So basically, we have x squared, which is all variable, no constant. Okay, so we can create a capital X, a dummy variable, and now if I put that back into the relation here, I will see that y equals 2 times capital X plus 1. Now what is capital X? It is basically x squared, but we have disguised it as x. Now here's the thing, if I were to draw that over here, and what I'll do is that I will create a table for this. Okay, now the usual table was that if we were to have, let's suppose, a table here, usually what do? We create values of x. So x is 1, 2, and 3. Then we usually put y in place of that, right? And we would see, okay, when x is 1, y is 3. When x is, so this is 3. When x is 2, y is going to be 9. When x is 3, y is going to be what? Can you calculate it? Tell me what it will be. In the original one, y is equal to 2x squared plus 1.
19.
90. Very good. Yeah, so that's a relation that we have, and we would usually plot it. So if I were to do that here, I'll get 1, and I'll put 3 here, then I'll get 2, I'll put 9 here, then I'll get 3, and I'll put 19 here. And let me zoom out a little bit, and you can see that all those points are there, right? You can see them in purple. Now I want to use the same one, but instead of having this, I'm going to create a new variable. And what I'll do this time is, instead of having this table where I have x and y, I will have 3 rows to this table. Okay, so that will be, I will have x, I will have x capital, and I will have y. So capital X is a bridge between the x squared and the y, and we are using it as a dummy variable. So when x is 1, same things. What is capital X? It is 1, it is 4, and it is 9. Now the values will still be the same, right? It will be the same. So फायदा क्या? We'll see in a bit. Now I'm going to draw this one. I'm going to draw a straight line, but this time I'm using a capital X for this. Okay. So capital X, 1, 4, 9. That's the capital X. And y is going to be 3, 9, and 19. Okay, and I will create a straight line here that is 2 times capital X plus 1. Oh, sorry. Yeah, there you go. So this is giving me a straight line relationship between between X and Y. But the difference is that instead of having a curve, I'm ending up having a straight line. Now there's no difference as far as the straight line and the graph is concerned. The values will be the same. Let's suppose you pick small x equal to 4. What will capital X be?
16.
60. Now that would mean that y should have what value? 33. Okay, that's the value we would expect y to have, 33. Now let's see, is that really what's happening here? Obviously, when when x equals to 4, that will intersect as 33. This is about the curve. But do we see that when we have a straight line? Let's see. So when x is 4, capital X is 60. Do we see that it has a value of 33? Of course we do. Okay, but the difference is that we have basically transformed that curve to a straight line, and now we can use the same ideas that we have for coordinate geometry, which includes distance formula, which includes gradient, which includes perpendicular lines, all those, but we can simply use a straight line. Straight lines are simpler, they are easier to handle compared to quadratics.
Yes.
Great. So the first part of this lesson is basically about figuring out straight line equations. All right. So we are going to figure out some relations for different graphs. Okay. So I have a simple equation here that y equals 3 over square root x plus 1. What would be our dummy variable? Remember that it has to be some combination of variables. No constants can be included.
Sir, can you please repeat it? I couldn't hear you.
So basically, we have this equation, this new one, and what we're trying to do here, this equation, if you can see, what we're trying to do here is that we are trying to figure out a relation between y and a dummy variable. Now, how do we make dummy variables? The first thing is you make sure that your curve is in this form: y equals mx plus c. What that means is that m is a number, c is a number, capital X is any combination of variables, capital Y is any combination of variables, and they are supposed to be our dummy variables. So let's try to separate this equation. So y
Sir, we
equals,
can't see the equation.
yeah, so I was saying that we have to have y equals m capital X plus c wherever we try to do this. So this is a dummy variable, this is a dummy variable, and dummy variable doesn't have to be one variable. It can be any combination of variables. It can be x plus y, it can be x squared times y, it can be y over x cubed, something like that. That just includes variables. Okay, it doesn't have any constants in it. That qualifies as a dummy variable. So here's the thing: we have y equals to 3 over square root x plus 1. If I were to plot this, then the plot will be a very weird one, like one that we wouldn't expect a student in maths class to be able to draw in the exam. Okay, let me show you what the graph would look like. So the graph would look something like, we wouldn't expect a student in your grade to be able to draw this graph in a short span of time in the exam. But what we can do is we can use the same values as this graph if we were to transform this into a linear log. So let's see. Let's separate this. We can make this as 3 times 1 over square root x plus 1, right? Now you can see here that this is y, this is another variable, and the other two, this and this, are just constant, right? This means we can have a relation here that is y equals 3 times capital X plus 1. And what is capital X here? So capital X here is basically 1 over square root x. So now we will obviously draw a table, and this table will have 3 rows. One will be x, one will be capital X, and one will be y, because we have one dummy variable and 2 regular variables. So we pick any value 0, 1, let's say 0, 1, and 0, 1, and 2. Now that would mean that x will have undefined value here. So there is no value going to be here because square root of x is 1 over square root of 0 is undefined, but 1 over square root of 1 is this. Now here's the thing. If I were to choose 2 here, it wouldn't be a smart choice because 1 over square root of 2 is an irrational value. So what will I do? I'll choose a value that I can easily plug in. So let me choose 4. Now 1 over square root of 4 is 1 by 2, and that I can easily plug in, right? So now y is undefined. Here y is going to be 3 times 1 plus 1, which is 4. And here it's going to be 3 times half. Instead of 3 times 1 over all that, it's going to be 3 times half plus 1, which is simply 2.5. So I will draw that, and this time I'm going to have simple values that y is equal to 3x plus 1. This is a line that I easily. So do you see that purple line? That is the line that we got from linear law. Now the good thing about this is, and interestingly, that the green line and the purple line, both of them are showing the same direction, except one is disguised version of the other one. And the purple line is easier to handle compared to the other one, which is why we use linear law. So I'm going to give you some relation, and I want you to figure out the relation. So for example, now I want you to create dummy variables for these.
Y over x will be a capital Y and x square would be a capital X.
Very good. So we simply have this as our dummy variable for y and this as our dummy variable for x, and everything else simply falls in line. Now, when we are going to draw a table for this, we will not draw a table with 3 rows. We will actually draw a table with 4 rows. Okay? We will have x, we will have y, and we will also have, let's suppose, we will have a dummy variable x and we will have a dummy variable y. Okay? So this is going to be a little more work than it might look like. So first of all, we are going to figure out, okay, when x is, let's suppose, 1, 2, and 3, what is y? When x is 1, we will use algebra and all that to figure out, okay, when x is 1, y is going to be what? 5.5. And when x is 2, y is going to be 14. And when x is 3, y is going to be, what is 9.5 times 3? 28.5. So that's what the y is going to be. Now we'll figure out x squared, which is dummy variable x. So it's going to be 1, 4, 9. And then we are going to figure out capital Y, which is going to be 5.5 here, 7 here, and 28.5 divided by, that's again going to be what? 9.5. So now we will draw this and we will be able to figure out whatever is happening. Now, what if we already have a graph? But we want to figure out what the relation is. We don't have a relation, we have a graph. So let me show that to you. So let's suppose we have this. We already have a graph and we want to figure out what the relation is. So first of all, notice that you already have dummy variables here. Okay, so the dummy variable here is LGY for y, and for x you don't really have a dummy variable. So we're going to simply write, okay, first of all, what's the gradient? We will simply ignore that this is linear law or anything. We will simply use the gradient, the formula that we have learned. So it is the change in y divided by change in x. Change in y is 5 minus 1 and change in x is 3 minus 1, which gives me positive 2 as my gradient. Now I do not have c, but I can easily figure that out using the formula y minus y1 equals to m times x minus x1. Remember that we talked about how we come up with this formula. So I'm going to pick a value. 1 and 1 is easy to handle, so I'm going to use that. And I will end up with y equals 2 times x minus 1. So that is my variables. But remember, this is not exactly y. This is in fact capital Y. So if you write this in the exam, it might be wrong. So if the examiner takes away a mark for you, you can't really challenge that. So always write it like this: 2x minus 1, because you have a dummy variable there. Now we can obviously figure this one out. We can see that dummy variable here is LGY. So we write LGY here. LGY equals to 2x minus 1. Now we make y the subject. How do we make that? You know that log is basically powers of 10. So we're going to convert everything to power of 10. So 2x minus 1. Then it comes to indices, 10 power 2x divided by 10 power 1, because the powers are subtracting. This gives me what? 10 power 2x is simply 100 power x over 10. There you go. You can't cancel it out. Remember, you can't cancel 0 with 0 and be like, okay, this is 10 power x. It's not. It's 10 power 2x divided by 10. So that's how you figure this out, the relation. Does that make sense? Now I'm going to give you a question and I want you to solve it. So it's a similar one. Have you found a gradient? You should be able to do that by now.
Minus 1 over 4.
This is minus 1 over 2.
Sir, is it not y2 minus y1 over x2 minus x1?
It is. It is. But make sure that you use capital Y, not regular Y.
Oh, sir, I'm talking about the gradient.
Yeah, so it is difference in Y divided by difference in X. So difference in Y is of 2 steps and difference in X is of 4 steps.
So it's minus 1 over 4, not minus 1 over 2. So you said minus 1 over 2, which is why I was.
Alright, so let's see. The gradient here is change in dummy variable y divided by change in dummy variable x. This is going to be 1 minus minus 1 divided by 2 minus 6, which is simply going to be 2 over minus 4, which is minus 1 by 2. Is that what you got?
Yes.
Okay. And now we'll figure out the equation. So y, if I do this, will that be correct? If I write y minus y1?
Right now, yes.
No. Yeah, but it won't be useful when I actually plug in the values. Okay. So it's just to be safe, I'll use capital values. So y minus y1 equals n x minus x1. Now the examiner doesn't really know what capital X and capital Y. So I'll just put that there. So this is going to be capital Y and this is going to be capital X. So capital Y minus 1, 1 equals to minus 1 by 2, capital X minus 2. I figured this out. So y minus 1 equals to minus half times x plus 1. And that gives me y equals to minus half x plus 2. All right. So we have figured this out. Now, obviously, we will change the equation. So we will use LGY equals to, now this should be small one, minus 1 by 2 LGX plus 2. Now we have simply, if you leave the question here, that's perfectly fine. If you want to further simplify this, I would suggest that you make log on both sides and then cancel it out. So we'll try to do that. For that, you will have to use form of 1. You know, this is log. This is going to be LG10, 2 times LG10, right? Because this is 2 times 1, which simply makes this LGY equals LG x power minus half plus LG 10 power 2. I'm using power law here, and we have already talked about it. If there's any issue, let me know. So LGY equals to LG x power minus half times 100, because I have 2 logs multiplying, so I'll add the 2 logs adding, so I'll multiply, and now I can cancel this log. I couldn't have cancelled it earlier on. Now I can. So y equals going to be 100 over square root x. Okay, so we have figured out the relation. So the main point here is that if you have the relation, you can figure the equation, and you can draw the graph. If you have the graph, you can figure out the relation by using the simple y equals mx plus c and all that. Okay. Now here's a question that you might find a little weird. Now remember LG7, LG81, LG63, they're simple numbers. This is another way of writing the numbers. They aren't really variables. So treat them as you would treat 1, 2, or any other such variable.
So 0.5.
Okay, now we'll find the equation. I'll do it in the meanwhile. You keep going on with that. There you go. We have found the relation. Now the next question is, what is the value of k when t is 9? So we can simply plug that in here. So we know that when t is 9, k is going to be 7 times 9 power half, which is going to be 21. Okay, we can simply do that. Now the last part of this chapter is basically using the data that they give us to figure out a relation and a straight line graph. So here's a simple question. We have the data, but we don't have a relation yet. So we will find that relation. How do we do that? We first start with the data that we have. So we're going to put that here. So this is 1, this is 2, 3, 4, and 5. Then we'll take the values of log. I don't have a calculator here, so I don't know if I can do that here. It's going to be 1.38 for this. So I'll do it for the next one. It's going to be log 6.31.
Sir, I'm
Yes.
using my calculator, and like for log 3.98, I have a totally different answer.
You will, because I'm using ln. I'm not using LG because I don't have LG here.
Okay.
Yeah. So, but my answer won't really differ as much. So I'm going to use these values. So I'm going to plug this in. I'm changing this to ln. Okay. So we have a graph here. Now I would suggest that you continue this graph and you actually make a straight line graph on this. Okay. So if you do that, it's likely that we will end up with a straight line graph, and we can use that graph to figure out the gradient. Now you pick any 2 points on this graph to figure out what the gradient is. Okay.
Sir, the gradient is 0.46. And what? Sir, I'm doing the equation right now.
Okay. Yeah. So we have to figure out the relation now. So y here is basically capital Y. Okay. So we know that this is going to be ln m equals to 0.46p plus 0.92, where my 0.92 is my gradient. Oh, sorry, y-intercept and 0.46 is my gradient. And now I'll make yn the subject, so it all becomes this, which is nothing but 0.92 power times 0.46 power. And you can obviously just show this. Now they're saying, what is the original mass of bacteria, or T? Original mass means when T is 0. And you can look at it from the graph that when T is 0, it simply becomes e power 0.9. Do not say 0.92 because that is not the mass, that is not n, that is ln of n. Okay, so either you can simply say that okay, ln of m equals to 0.46 times 0 plus 0.92 and then solve the equation. So you'll end up with ln m is equal to 0.92, m equals e power 0.9. Either you do that or you use the relation that you have figured out and then you plug in 0 in here. Okay, so that's a common mistake the student would say that, oh, this is 0.9.
Yes, sir.
Yeah, so we are done with linear log here. These are the third kind of questions that we usually ask. And you guys, I hope you understand this. If there's any problem, do ask now, or you can ask me later. That's perfectly fine. So I'll send you some review problems to solve. Yes.
सर जो ऊपर सबसे आई थिंक सबसे पहले जो हमने इक्वेशन की थी उसमें हमें y के सारे आंसर्स पता चल गए थे हाँ जी जो ये था जिसमें हमें y is equals to 4 y is equals to 2.5 वाला जो था
Yeah.
इसको हमने प्लॉट किस तरह किया था?
I plotted it in this purple line.
नहीं पर like
No.
किस तरह like values किस तरह डाली थी?
Value किस तरह से डाली? We basically had capital X on the x-axis and small y on the y-axis. So I simply plugged in 1 and 4 and half and 2.5 and I was able to do it.
Okay.
It's not shown here.
So we will save.
Yeah.
Thank you.
Yeah, that's it.